Hi, it's Ms. Logan. Today I'll be going over 2D motion, which is also known as projectiles. Let's talk a little bit about what projectiles are. So projectiles, anything that's going in the x direction and the y direction. The most important part about projectiles is that my x is independent of my y. They are in different universes, different sides, okay? Whatever happens in the x is different from the y. Let's think about y. So if I fire this cannon right here, and there's no gravity, we know from inertia that this cannon would travel forever and ever and ever, unless it ran into something. But because we have gravity, gravity is going to be pulling it down. So I have two different things going on here. In the x direction, everything is staying the same. There's no acceleration. And the only thing going on in the y is that gravity is pulling that object down. Let's talk about the rules in the x and the y direction. So like I said before, if I am throwing a ball up in the air and it comes down, everything in the x and y direction is going to be independent of each other, okay? So let's talk about velocity in the x. So velocity in the x stays the same. So what does this mean? Well, my velocity initial equals my velocity final the whole time. However, my y direction, it depends on the situation. So if we are firing something only in the horizontal, we are only going to have a horizontal velocity. When we're throwing something at an angle, we'll have velocity in the x and the y. So it really depends on the situation. For acceleration, in the x direction, there is zero acceleration. Okay, we do not have any acceleration or gravity in the x direction, it's only in the y. So for acceleration in the y direction, it's always negative 9.8 meters per second. The time, in both directions, it is the same. So if I find my time in the x, it's the exact same in the y. So here are my steps. First, I need to read the problem and underline important information. Then I need to separate my variables into the x and the y. So you'll see in a second that I separate into a t-chart x and y, and I put all my variables down that I know. Don't forget the rules from the previous slide. Sometimes the best way to start is writing down everything you know, and you don't want to forget about those extra things like what acceleration is in the y. Then you need to solve the x separately from the y. You can't cross these numbers, they're two different universes. All right, let's dive in and try to solve a problem. So my first situation is horizontal velocity only. So whatever we're doing is just being shot out in the horizontal direction, and then we notice it will fall down in a pattern like this. So a pool ball leaves a 0.6 meter high table with an initial horizontal velocity of 2.4 meters per second. So we need to figure out the time required to fall on the ground and the horizontal distance between the table's edge and the ball's landing. All right, so my first step for these problems is to always set up my x and y chart. Okay, so let's set this up in my x and y t-chart, and let's fill in what we know. So my x direction, my initial velocity is 2.4 meters per second. Remember, it will stay the same throughout, so my final velocity is still 2.4 meters per second. Gravity does not affect my x. So in this, we're looking for delta x, and we're also looking for time. Let's go to my y. So the first thing you should always be writing down is acceleration, negative 9.8 meters per second squared. And in these type of problems, when I'm only firing something in the horizontal, my velocity initial will be 0. It also told us that my delta x is 0.6 meters, and I'll be also looking for time. So my next step is to figure out which equation I need to use, okay? Now, I have 3 variables in my y direction, so I need to find an equation for this. let's take a look. Which equation should I use? Well, I would use this equation so I can plug in and solve for t. All right, so I have delta x equals VIT plus 1/2 AT squared. I need to solve for t. So I have t equals square root 2 delta x over a. I was able to get rid of VI because it's 0. From here I can plug in my numbers, and I'm going to get a time of 0.35 seconds. Now, at this point, I can use that time in my x. So my x, I have my initial and final velocity, and now I have my time. So now I can look for delta x. Which equation I'm going to use? Well, because I do not have any acceleration, anytime the only equation I can use is my final kinematics equation. Remember, this one is not given to you on the AP test, but it's probably worth memorizing. All right, so I'm solving for delta x, so I can plug in my numbers from here. When I reduce, it will look like this. So for my final answer, I should get 0.84 meters. Let's move on to a projectile at an angle. All right, so a football is kicked with initial velocity of 25 meters per second at an angle of 35 degrees. Determine the time of flight and the horizontal displacement. Now you notice in these problems they don't give you a lot of information, but that's fine. Let's draw out what's going on. So this is being sent off at an angle, 35 degrees at 25 meters per second. So it's going up, and then it's going to go back down. So when this thing lands, my final velocity is going to be negative 25 meters per second. It goes up and it's going to come back down. Everything is going to be the same. All right, so let's look at what this is going to look like. Okay, split up into my x and my y. Okay. Now, before I even get started, I need to figure out my x and my y components. So I can use a little bit of SOHCAHTOA to help me out with this. And I'll let you do this part on your own. When I separate my x and my y components, for my x I'll get 20.48 meters per second, and my y I'll get 14.34 meters per second. So before you make your x and y t-chart, you need to separate your x and your y components when we're at an angle. All right, so for the x, my v1 and my v final are the same, 20.48, okay? Now, I'm looking for my time, and I'm also looking for delta x. So how far did it travel in the x direction? My y direction, my initial velocity is 14.34 meters per second. And when it hits the ground, it's going to be negative of the same. My acceleration is negative 9.8 always. And I'm looking for time. All right, so which equation am I going to use? Well, I should use this one because I do not have delta x. So we're solving in the y direction right now, and I'm using my first kinematic equation. Okay, so I'm solving for t, so we need to rearrange our equation to solve for t, and then we plug in from there. Now I'm going to show you what this looks like plug in. So I'm going to get negative 14.34 because that's my final, minus 14.34 over negative 9.8. My answer should be a positive 2.93 seconds. Cool. So last thing I need to solve for in my x direction is my delta x. So let me just write this down. So it might be a little easier on your paper because you already have it written down. But I have my time now. Now I'm solving for delta x. So we're going to use the same equation as before. Once again, this one is not given on the AP exam, so it is worth memorizing this to help you out a little bit. From here, I can plug in my numbers and solve for delta x, which I encourage you to do right now. So I will get a total distance of 60 meters. Our final situation is going to be peak height, okay? So this is the same problem as before. So because we're just worrying about height, we're only looking in the y direction, okay? So when we're looking for the peak height of something, we need to create a new y chart. Why? Well, my initial velocity, as we know from doing our trig, is 14.34 meters per second. But when this reaches the very top, what is it going to go to? Velocity final equals 0. My acceleration is still negative 9.8, and we're looking for delta x. So take a moment, which equation do I need to use? I'm going to use my second to the last kinematics equation, 2a delta x. So I am solving for delta x. So I'm going to rearrange this equation for 2a. So for my final answer, when I plug in my numbers for my new t-chart, I should get 10.5 meters. All right, so thank you for listening to the flipped lesson. We'll be working a lot with projectile motion during class. Really, with projectile motion, practice makes perfect.